Alright, what's up YouTube? I'm back, and today we're talking about the limits of trig functions. So I think we start any, um, as everyone should, start any talk about trig functions with our humble unit circle. So we'll go, this is a unit circle, there's our axis, and let's say, right, if we're talking about sine, well, sine is this value on kind of the y-axis versus the x-axis when we form some angle theta, right? And so we know that as we keep going around, as we approach pi over 2, we're going to approach 1. And then we're going to go, it's going to fall back down as we approach pi. And as we approach pi over 3, it's going to go all the way down, keep going down, to the negative 1. And we go back, we have more and more angle. As we keep increasing our angle, we're going back up to 0, right? And so we're going to be kind of bounded between, if we kind of graph this on, a geometric graph, we're bounded between positive 1 and negative 1, right? And so when theta is 0, sine starts at 0, so we have a point here, and we go up, and we go down, and we go up, and we go down, and we go up, right? And that keeps going on forever. So if you're looking for the end behavior of this graph, right, or the limit as x approaches infinity of the sine of x, you're not going to find it, right? And so the limit does not exist, right? I write open set with a 0 with a line through it, which means there's no solutions. You could write it as does not exist, whatever, what have you. And the reason for this is it oscillates, right? So it goes between it oscillates between, I guess, inclusive negative 1 and 1, right? So it'll go between negative 1 and 1, and it'll keep doing that forever. We could look, when, x on this axis, so x, when x is 10, it's still oscillating between negative 1 and 1. If we look, a million, billion, trillion, when x is a million, billion, trillion, it's still going to be somewhere between this positive 1 up here and this negative 1 down here. It's somewhere on the unit circle there, right? So we can't actually take the limit as x approaches infinity directly of the sine of x. But, I wouldn't be making this video if I didn't have a but. If I didn't have a purpose, I also wouldn't be making this video. We can in fact take the limit as x approaches some value, we'll call it, I don't know, pi over 2 of the sine of x, right? So, okay, so what is that? Well, as x is approaching, or as the sine of x is approaching pi over 2, we can use direct substitution here and say, okay, what's the sine of pi over 2? Oh, the sine of pi over 2 exactly is positive 1. So the limit as x approaches the sine of x equals 1, right? And we know that's true because we can kind of intuitively check the limit from the left. From the left is approaching 1, and then from the right is also approaching 1. So that is awesome. All right, let's try a more complicated example. What is the limit as x approaches pi over 2 of 1 plus the sine of x minus pi over 2, right? Okay, well, this is a little more complicated, but I think we can still do it, right? So what if we say this is, we can directly substitute this in. We can say it's 1 plus the sine of x minus pi over 2. So when x is pi over 2, it's pi over 2 minus pi over 2, which is 0. And the sine of 0 is 0, so that just cancels out, and we're left with 1, which is the right answer. All right, let's keep going. And this time I want to try the limit as x approaches infinity. X approaches infinity. And I'm just going to go ahead and say, what is the sine of 1 over x, right? So with this one, what we can do is we can really break it down into what is the limit as x approaches infinity of 1 over x, just independent. We can find that limit and plug that into the sine of x, right? So the limit of here, the limit of 1 over x, well, as you are dividing by a larger and larger number, your fraction, your value, is getting smaller and smaller and smaller. If we think about the graph of 1 over x, we have whoop, and that, right? Right, so as we're getting closer and closer to 0, keeping it positive, right? Or rather, I'm going to positive infinity, sorry. As we're getting closer and closer to infinity, positive infinity, we're actually, the value is going from, high value up here, down. It's going towards 0. It isn't ever going to be 0, but it's getting really close to 0. So we could say the limit as x approaches infinity of 1 over x equals 0, and we can substitute that back in and say it's the sine of basically 0, which is just 0, right? So the limit as x approaches infinity of the sine of 1 over x, that is 0. Cool. Let's do one with cosine. Let's do a complicated one with cosine. Let's go on what is the limit as x approaches 0 of the cosine of 1 over pi, or not pi, 1 over x plus pi over 2. Right? Okay. This is an interesting one. Okay, so we have the limit as x approaches 0. We're just going to say, again, direct substitution is almost always going to work for these kind of basic rudimentary ones. We have 1 over x equals 0, 0 plus pi over 2, right? Okay, well, 1 over pi over 2 is the same as 2 over pi, right? That's kind of the inside. So that's equal to the cosine of 2 over pi. And 2 over pi is not a common unit on the unit circle. It's not a common ratio measurement, but it is some sort of angle, right? Because pi is just a number, and 2 is just a number. So we're really just looking at the cosine of some angle, and that, in fact, in most calculus courses is going to be completely reduced. That is the simplest form you can get it without converting it to a long kind of burdensome decimal. Awesome, good work. So basic limits of trig functions. If you have any specific problems, or if you have any kind of questions about what happens if this happens or whatnot, let me know. I'll make another video, and